Welcome. We're going to finish out Chapter 8 today with Section 8.4, the determinant of a square matrix. Our goals for today that you can find the determinant of a 2 by 2 matrix, you can use determinants to find the inverse of a 2 by 2 matrix, and that you can solve equations involving the determinant of a 2 by 2 matrix. For those of you looking for a little extra challenge, the last couple slides in the presentation involve these last two learning targets, finding the determinant of larger matrices and discovering properties of determinants. Let's start with the definition. The determinant is a special number that can be calculated for any square matrix. And for a 2 by 2 matrix, matrix A with terms A, B, C, D, the determinant is given by the formula AD minus BC. Notice we have two different types of notation here. Sometimes you'll see this, especially on calculators, the abbreviation determinant of matrix A. In your textbook, you'll often see this notation here with matrix A in what looks like absolute value symbols, but in matrix notation, this does mean the determinant of matrix A. Notice that this formula gives us a number, and it's calculated by subtracting the products of the two diagonals in the matrix. So you multiply the first diagonal, A times D, you multiply the second diagonal, B times C, and you subtract those two values. You can read through this if you're interested in knowing where it comes from. It relates back to systems of equations and has a tie into the discriminant and quadratic formula. For example 1, we're going to find the determinant for each matrix. For A, matrix A, first row has terms of 2, -1. Our second row is 3 and 5. We're going to multiply our first diagonal, 2 times 5, minus multiply the second diagonal, -1 times 3. 2 times 5 is 10, -1 times 3 is -3. And when we subtract 10 minus -3, subtracting a negative is like adding, so we get 10 plus 3, and the determinant of matrix A is 13. For example B, matrix B has a first row of -4, 1, and a second row of 5, 0. Same process. We're going to multiply our first diagonal, -4 times 0, minus multiply your second diagonal, 1 times 5. -4 times 0 is 0, 1 times 5 is 5, and 0 minus 5 means the determinant of matrix B is -5. For C, matrix C has a first row of 3, -3, a second row of -2, 2. 3 times 2 from our first diagonal, minus -3 times -2 from our second diagonal. 3 times 2 is 6. -3 times 2 is also 6, and 6 minus 6 means the determinant of matrix C is 0. Finally, matrix D, a little more interesting for those of you that will appreciate this. Our first row is x, then 4. Our second row is 1, then x. If we multiply our first diagonal, x times x, minus multiply our second diagonal, 4 times 1. Well, x times x is x squared. 4 times 1 is 4. And so the determinant of matrix D is x squared minus 4.